Okay, lesson 9. This one's pretty quick, but lesson 10 takes a little bit longer. I think the end of this unit is kind of easy. This is just applying everything we've learned about sinusoidal functions so far. This one's going to be, if you're given the function, can you analyze it? And that's pretty easy given our graphing calculators. And then the next one is come up with the equation and model it. Okay, a function whose graph resembles the sine or cosine curve is called a sinusoidal function. Many periodic phenomenon have sinusoidal graphs. They don't necessarily have sinusoidal graphs, but they can be represented by one. Maybe perfectly, maybe imperfectly. But some common examples, and these are really the three very most common examples. Time of sunrise as a function of the day of the year. So our sunrise goes up and down, and it keeps waving like that. The height of something as it moves around a circle. So the classic one is a Ferris wheel. So how high are you at what given time? And it's going to go up and down, up and down. And then the depth of the ocean are tides. Our tides also go in and out. And that's also a periodic function. So we're going to be looking at two types of these. One, if you're given the actual equation, and then two, if you have to come up with it. And this is going to be 9, and this is going to be 10. So let's try it. First problem, the minimum depth, d, of water in a harbor after t hours after midnight. So you have to always relate it to some kind of real life time. So t is hours after midnight. Can be approximated with the function, blah, blah, blah. Okay, determine the maximum and minimum depths of the water in the harbor. Well, where's the middle? That's the first thing we want to know. Where's our horizontal axis? Where's that k value? And that's going to be at 12. So because it's at the beginning, really it should be at the end, but it's fine that way as well. So 12 is the middle of our function, and then how much higher does it go and how much lower does it go from there? And that comes from our amplitude, which is our a value, which is 5. So it should go 5 units higher, so it should go up to 17. And it should also go 5 units lower, which is down to 7. So a total range of 10, which makes sense. What's the period of this function? So period is equal to 2 pi divided by k, which is equal to 2 pi divided by 0.5. So it actually grows. It doubles up to 4 pi. So it should take 4 pi to happen in this case. If we want to graph it with radian measure. If we want to graph it the other way, then it's going to be different. Of course, it would be 360. It would be 720 of whatever our t is, which is hours. Okay, what's the depth of the water to the nearest tenth of a meter at 2 a.m.? Okay, so this is going to be a graphing problem. So punch this into your calculator. Oh, you have a C that I missed. What kind of window should you use to look at this? This is kind of up to you, but we know, at least for the y values, it's kind of, we already have the answer. So it's got a minimum of 7, maximum of 17. So maybe we want to go to 5 to 20 with every 1 maybe for our window for our y values. And what about x? We want to go from the dog's barking. 0 to 24. And we'll go every 2 hours. Because we'll do 1 full day. It says we only want to graph it from 0 to 24. So it makes sense to do it 0 to 24. Okay. What is the depth of the water? So graph this, and what is it at 2 a.m.? And this is a solve question. You want to put in another equation when x equals 2. Actually, you could do this a couple different ways. So you want to graph the function, you could scroll till you get when x equals 2, you can just look, or you could turn it into a table of values and enter in 2. One of those ways, you should get a y value of 14.7. So therefore the depth of it is going to be 14.7 meters at 2 a.m. That's a fairly easy one because it's a single x value. What is it at 2 a.m.? A ship which requires a minimum of 8.5 meters of water is in the harbor at midnight. By what time to the nearest minute must it leave to prevent grounding? So again, we're going to use this by graphing. I put stars beside all the ones that are graphing ones. Most of the ones in this unit we're going to solve by graphing if we can. And if you have the equation, almost always you can. So we want to know when is the first time it's going to have a water height of 8.5 meters. So what we want to do this time is we want to graph the intersection of d of t and the line, height line of 8.5. So all you have to do is put in another line in your calculator with 8.5 as the value, and that'll create your horizontal line. And then you're going to find the point of intersections between them. And we care about the first point of intersection. So it'll have to left bound and right bound. And you want to find that first point of intersection. So when must they actually leave by? If you do that, you should get an x value of 4.69. Now what does this mean? We need to convert this into time. So whenever you have decimals and you want to convert into time, you always do the same thing. Hopefully you guys can already kind of figure this out. That is going to be 4 hours and some amount of minutes. It's going to be 69 out of 100 of 60 minutes. So all you actually do is times that by 60. So 0.69 times 60 is equal to, I get 41.4, so 4 hours and 41 minutes. Should be about the answer. And then what is this actual time? This is the amount of time past midnight. So this is 4:41 a.m. is our actual answer. Little bit of conversions to do at the end. We have to go from there to there to there. Okay. What is the next minute to the nearest necessary minute? That means we're going to be rounding up probably. That the ship can return to the harbor. So when will the harbor again pass 8.5 meters, but this time be deeper then? So if we're looking at it graphically, this is going to be our 8.5 meters line. So we said it goes lower than. That was our first point. We have to leave by that time because it's going to be too low, but we can return at this time here. So we want to find that next time that it's going to be bigger than. So again, just find the next point of intersection, and you should find equals actually I don't have the answer here. 7.87, something like that. Now we need to convert this into time. So again, it's 7 hours. And what is 0.87 times 60? Is 52 minutes. Now they said to the nearest necessary minute. They cannot arrive back in the harbor after 52 minutes, 7 hours and 52 minutes. It's still too short. So it's going to be 7:53. After midnight. Okay, so just some graphing questions. Last one for part 9. So now we have this function, and this is representing our sunrise, where t is the time in hours. So our actually y value is the time that's passed in hours. Or sorry, not time that has passed. Yeah, t is the time of the sunrise in hours after midnight. Not the time has passed. The d is the number of days that has passed. T is the time of the sunrise. That's why D is the independent variable here. And D is the number of days in the year after New Year's. So what day of the year is it? So what is a suitable window for this? For our x values, we'd want to go 0 to 365, do all the days of the year, and maybe make it change by a scale of 30. For our y values, our middle is going to be 6.3. So it's roughly 6.3 hours is the average time after midnight. And then the range is 1.79. So we want to add and subtract that. So it's going to be something like 7. It's going to be something like 8 and 4 or less than 4. So I'm going 2 to 10. That should be able to see everything that goes above the top peaks and under the minimum peaks with a scale of 2. Okay, so you should graph that. Pause this and graph that. Just take a drink, my throat's sore. Okay, not a graphing one this time. Use the formula to determine to the nearest minute when the sun rose on May 7th, the 127th day of the year. Which just means all we have to do is sub in D equals 127 into our formula. It's a little bit of a complicated formula, but it's actually not too bad. So we would sub in, we would say T equals negative 1.79 times the sine of 2 pi over 365 of 127 subtract 78 plus 6.3. Now remember, we have a sine thing, so you have to be in the right mode. We have pi's in here, so we have to be in radian mode. So plug all that into your calculator in radian mode, and you should get an answer of 57.76. Sorry, that's not right. 4.9629. Something like that. That was one step further. So again, we need to turn this into time. So it's 4 hours, and what is 96th of the way to the 5th hour? So 0.96 times 60 is our 57.76. So it should be roughly 4. I got that calculation. 0.96 times 60 is 57, or roughly 58 to the nearest minute after midnight. So 4:58 a.m. Good. Determine on which days of the year will the sun rise at 7 a.m. So this time we want T equals 7 a.m. Now this would be a hard question if you didn't have the graphing calculators. If you didn't have the graphing calculators, you would need to take this formula. So you'd subtract 6.3, you'd divide by that number, then you'd sine inverse, and remember you'd only be finding the first answer, and then you'd solve the rest of this for D. And that would find you the first answer, and then you would have to think of when is the sine negative times the sine of something going to be a positive number. And then you would have to find all the quadrants, and you'd find all the other solutions as well. It would actually be quite a challenge. This would be an extremely hard question, and maybe we'll do, I'm not sure if there'll be one like that in the next section. We'll see when we get there. But we have the graphing calculator, so all we need to do is go into the graphing calculator, make a line where a horizontal line at 7, and then find the points of intersection. There should end up being 2 of them. You should find x equals 54.66 roughly, and another x equals 283.84. And we would probably round these to the nearest day. Which day is that actually? So day 55 and day 284. Good. With a graphing calculator, this becomes much, much easier. Without a graphing calculator, this would really be testing our skill. It would be bringing in everything from our unit, our multiple solutions using trig and stuff. But we had the calculator. So if you have a calculator and it doesn't tell you to do it by hand, almost the entire diploma is multiple choice or numerical response. So you can almost always use your graphing calculator. Only on the written parts will you have to actually do something by hand. Okay, that's it for 9. Only 15 minutes, 16 minutes, not too bad. 10 takes a little bit longer though, so we'll jump into that.